Welcome to The Explainer. Today, we're going to uncover the hidden journey of pretty much every single object you own. We're talking from that first spark of an idea all the way to the thing you're holding in your hand. Let's see how it all comes together. I mean, really. Have you ever just stopped and looked at something? Your phone, the chair you're in, even your coffee mug. None of it just appeared. Every single curve, every button, every material was a choice, part of a really fascinating and deliberate process. In that whole process, it has a name, the design cycle. You can think of it like a secret map that guides an idea from just a thought into a real thing. And the most important word here is iterative. It's a loop. Designers go through it again and again, tweaking, refining, and improving until a product is absolutely perfect. So here's our game plan. We're going to follow that exact path. We'll start with research, where it's all about asking the right questions. Then we'll make things real with a prototype. After that, we dive into the most critical part, the test and optimize loop. Then we'll see how it's all drawn up for the real world. And finally, we'll see how the cycle literally redesigns the world around us. Okay, first up, research. Now, you might think making something starts with, making something. But nope. Before a single tool is picked up, the most important work is all about understanding. It's about digging deep into the problem you're actually trying to solve. And right away, designers face this huge balancing act, function versus form. On one side, you've got aesthetics, how something looks and feels. That beautiful sculptural armchair, pure aesthetics. It's art. But on the other side, you've got ergonomics, how it actually works for a human. That's your super adjustable office chair. It might not be pretty, but it supports you all day. The real magic, the best design, lives in that sweet spot right in the middle. Let's just zero in on ergonomics for a second because it's so critical. It's the whole science of making things fit us so we don't have to awkwardly fit the things. You know, when a tool just feels right in your hand, or the controls in a car are exactly where you'd expect them to be, that's good ergonomics. It's all about comfort, efficiency, and, of course, safety. So this entire research phase really comes down to this checklist. What is this thing even for? Who is going to use it? How do we balance making it look cool with making it easy to use? And is it safe? Nailing these questions from the get-go, that's everything. Okay, with all that thinking and research locked in, we get to move on to the really fun part, prototyping. This is the moment an idea stops being just words and drawings on a page and becomes a real physical thing that you can actually hold in your hands. And creating a prototype isn't just messing around in a lab. There's a clear path. You start with a preliminary design, basically your first blueprint. Then you have to choose your materials. Is it plastic, metal, something else? Then you actually build it. And finally, you get some feedback and you refine it. And remember, this is its own little loop. You might do this a few times before you get it right. Today, prototypes are usually built in one of two main ways. First, there's additive manufacturing. Think 3D printing. It starts with nothing and adds material, layer by tiny layer, to build something up. The other way is subtractive manufacturing. This is more like sculpting. You start with a solid block of material, and a machine, like a CNC mill, carves away everything that isn't the final part. All right, you've got your physical prototype. Now comes what is arguably the most important phase of all, testing and optimization. And it's not just a single step, it's a relentless, continuous loop. You build it, you try to break it, you learn from how it broke, and then you make it better, over and over again. I mean, this quote really says it all. The key word is repeated. This is iteration. Nobody, and I mean nobody, gets a complex product perfect on the first try. It just doesn't happen. The goal isn't to succeed immediately. The goal is to fail, but to fail smart, so that every single version gets you one step closer to the right answer. So what does this testing actually involve? Well, there's usability testing, where you put the prototype in front of real people and just watch. Do they get it? Is it easy to use? Then there's performance testing, where you push it to its physical limits to see if it'll break. And more, there's virtual testing, where you do all of this inside a computer, saving tons of time and money. Sometimes that performance testing gets pretty extreme. I'm talking about destructive testing. That's when you build a very expensive, very perfect prototype for one reason and one reason only, to completely destroy it. Think about a car crash test. It seems so wasteful, but it is often the only way to be 100% sure a product is safe. Now, to avoid having to smash a brand new car every single day, designers rely heavily on virtual testing. The software we have today is unbelievable. It can simulate almost anything, letting engineers run thousands of digital tests that save just an incredible amount of time and money. It's a total game changer. For instance, there's a type of simulation called finite element analysis, or FEA. This software basically tests a part for strength. It can show you exactly where a component is going to bend or crack or just completely fail under pressure, all without ever building a thing. Then there's another amazing tool called computational fluid dynamics, or CFD. This one simulates how liquids and gases, like air or water, flow over and around an object. This is absolutely essential for perfecting the aerodynamics of something like an airplane or, you guessed it, an F1 car. And speaking of F1, to give you a sense of just how intense this optimization loop can get, a single team might test hundreds of different designs and prototypes for one single part, like a rear wing. Each tiny change might only offer a nearly invisible improvement, but when you add up all those tiny gains, that's what wins races. Okay. The design has been researched, prototyped, tested, and optimized like crazy. It's perfect. So how do you communicate that final, perfect vision to the people who are actually going to manufacture it? You use the universal language of engineering, technical drawing. And there are three main ways to draw an object in 3D. An oblique drawing is pretty simple. It focuses on the front face. An isometric drawing shows a corner view where all the proportions are true to size. This is key for technical accuracy. And then a perspective drawing uses vanishing points to show how an object would actually look to your eyes in the real world. Now, along with the drawings, you need the recipe. This is called the bill of materials, or BOM for short. Think of it as the complete master shopping list for the product. It lists every single part, every screw, every wire, every scrap of plastic, everything. If it's not on the BOM, it doesn't get built. Simple as that. So how do the people in the factory know how to put it all together? They use assembly drawings, and especially these cool exploded views. It's literally the visual instruction manual, showing how every single one of those components from the bill of materials fits together perfectly to create the final product. So there you have it. From a simple question, to a sketch, to a prototype, to breaking it, optimizing it, and drawing it, that is the journey. This design cycle isn't some abstract idea in a textbook. It's the living, breathing process that's responsible for the shape, the feel, and the function of almost every single man-made object in your life. So, I'll leave you with this one question. The next time you pick up your phone, or sit in your favorite chair, or use any tool at all, just take a second, look at it. Knowing the incredible journey of thought, trial, and error it went through to exist, what do you see differently now?